So how about a square root problem? These you've already done a couple of times in the past. Let's just review a little bit. Remember, the first thing you want to do is isolate the square root. So we need to move this 12 to the other side. We'll have the square root of x So remember, whenever we did the square root equations before, the very first thing that you need to do is isolate the square root, or isolate the radical. So in this case, we're going to move the 12 to the other side, and we get the square root of x is equal to x minus 12. To get rid of the square root, we're going to have to square both sides. So it'll look something like that. The square root and the square will cancel each other out, and you're left with x equals, keep in mind this means x minus 12 times x minus 12. It does not mean x squared plus 144. So be really careful about that one. We'll have x is equal to x squared minus 24x plus 144. Now we're going to subtract x from both sides because we need it to be equal to 0. So 0 is equal to x squared minus 25x plus 144. At this point, you can see if it will factor, or you can use the quadratic formula. Let's see which one we need to try. So if we were going to try to factor it, we need factors of 144 that add up to a negative 25. So we know that they both need to be negative. Let's just see what we can come up with. 1 times 144, 2 times 72, 3 times 48, 4 times 36, 5 doesn't work. 6 times 24, if you add those you get 30, that's getting closer. Then we have 8 times 18, that doesn't work. And then we have 9 times 16, that one does work. So we can factor it. We have x minus 9 and x minus 16. Set both of those equal to 0. And solve. So you get x equals 9 or x equals 16. Now you should check both of those and make sure they work. What's the square root of 9? The square root of 9 is 3. 3 plus 12 is 15. That is not equal to 9. So let's try 16. What's the square root of 16? 4. 4 plus 12 is 16, and that is equal to 16. So 9 does not work, but 16 does work. Okay? So what if you have 2 square roots in the same problem, or 2 radicals in the same problem? You could square it as it is, or you can isolate one of the radicals. I actually do like isolating one of them. So I'm going to move this square root of x to the other side. I get the square root of 3x minus 2 is equal to the square root of x plus 2. Now I'm going to square both sides. When I square both sides on the left, these go away, and I get 3x minus 2. But on the right, I get the square root of x plus 2 times the square root of x plus 2. So I have 3x minus 2 is equal to the square root of x times the square root of x is the square root of x squared, which is x. Square root of x times 2, 2 times square root of x, and 2 times 2. So we have 3x minus 2 is equal to x plus 4x plus 4 square root of x plus 4. Let's see if we can isolate this radical. So we're going to subtract x, and we're going to subtract 4. So these go away, these go away. We get 2x minus 6 is equal to 4 square roots of x. Now we do have this term isolated. We can go ahead and square both sides again to get rid of that square root. So square and square. On the left, since I'm running out of room, let's see if I can scroll a little bit. Not too much. I'll go ahead and square this one for you. So you're going to get something like 4x squared minus 24x plus 36. And on the right, square all of this. 4 squared would give you 16. And then the square root of x squared is just x. Then you need to subtract 16 from both sides, or 16x. So you get 4x squared, and then negative 24 and negative 16 is negative 40. And then that's plus 36 is equal to 0. So at this point, we could factor a 4 out. We'll be left with x squared minus 10x plus 9 equals 0. This will factor. We're going to have x minus 1 and x minus 9. If you divide both sides by 4, then the 4 is just gone. If you don't realize that, you can just set each of the factors equal to 0. 4 equals 0 doesn't make any sense. So then we add 1 to both sides. X is equal to 1. And then we add 9 to both sides. So x is equal to 9. Now we do need to go have a look at our original problem. Make sure that both of those work, the 1 and the 9. So let's see what happens when we put a 1 in here. 3 times 1 is 3. 3 minus 2 is 1. The square root of 1 is 1. And here the square root of 1 is 1. Is 1 minus 1 equal to 2? It's not. So 1 doesn't work. Our other answer that we had was 9. So if we put 9 in there, does it work? 3 times 9 is 27. And 27 minus 2 is 25. The square root of 25 is 5. The square root of 9 is 3. And 5 minus 3 is 2. So 9 works. 9 works, but 1 does not. So this is going to be our solution. Okay, how about number 7? These are usually the easiest problems to work, but they're the first ones everybody forgets. So have a look, see if you can remember this one. Remember that 2/3 power means the cube root of x, and it's all squared. It could also mean the cube root of x squared. It's just depending on how it helps you to write it, because both of these mean the same thing. Well, to get rid of a cube root, wouldn't you cube it? And to get rid of a square, wouldn't you square root it? Well, if that's the case, it's the same thing as raising it to the reciprocal power. So what we want to do is take this equation, let me just rewrite that so we can see what's going on. X to the 2/3 equals 4. We're going to take that power and reciprocate it. So we raise it to the 3/2 power. Now remember, if this denominator is even, like a 2, 4, 6, 8, like that, you need to do the plus or minus, because it's like taking a square root. Now that you have that, these will cancel each other out, and you're left with x equals plus or minus. What does this mean again? The 2 makes it a square root. The 3 makes it cubed. So it looks something like that. Well, that's going to be plus or minus 2 cubed. So that's going to be plus or minus 8. So x is equal to plus or minus 8. You can check that in your calculator as well. You can store your 8 and then do x to the 2/3 power, and you should get 4. Now store your -8, type in the formula, and you do get 4. So they do both work. So then how would we work number 8? For number 8, we have something raised to the -5/2 power. So to get rid of that -5/2, we're going to raise both sides to the -2/5 power. Raise this to the -2/5 power. Now you're not taking an even root this time, so there's no need to do plus or minus. So now these are going to cancel. You have y minus 2 is equal to 32 to the -2/5. Negative exponent means flip it over. And once you flip it over, the exponent becomes positive. So we have y minus 2 equals 1 over the 5th root of 32 squared. So y minus 2 is equal to 1 over the 5th root of 32 is 2, and 2 squared is 4. Now we add 2 to both sides, so y is equal to 1/4 plus 2. Now remember, 2 could be the same thing as what over 4. 2 equals what over 4 is equal to 8 over 4, right? So let's just change this to y equals 1 over 4 plus 8 over 4. And we get y is equal to 9/4. Let's go back and check the answer. 9/4 is what we're trying to check. So in my calculator, I store 9/4. Then I just type in the equation. So we're going to have x instead of y. X minus 2 raised to the, parentheses, -5/2 power equals, and I do get 32. So my answer seems to be correct.